Welcome back. So let's see now how we can visualize the tree. Okay, so first we need to get the features names, right? And to do so, we will go to xtrain encoded dot columns and convert this to a list. So if we do so, right, let's print the features names, and as you can see, we have all the features in a list. Okay, so this is a start. Now after that, we are going to create a dot object or a dot class. So what is the dot class? It's the one that we are going to create the graph from. So how we can do so? Using the string IO. Okay, so the string IO, we got it or we imported from a library called sex. Okay, so if you remember in the very beginning, we imported extra libraries and this was one of them. We imported from sex a string IO. So this is text IO implementation and it will basically return a dot object, right? So as you can see, string IO dot data is a string IO inst. Now this is the most important line in this code. Here we are using the export GraphViz, and this is actually from sklearn. So this was implemented specifically for visualizing the decision tree or seeing the decision tree. And as you can see, it's saying here, export a decision tree in dot format. This function generates a GraphViz representation, okay, of the decision tree, which is then written into output file. So we need to take care of this output file. Once exported, graphical renderings can be generated using, for example, and these are some examples to generate the graph. Okay, and here we have the parameters. So the most important parameter, of course, is the decision tree itself, so the classifier, and the output file. By default, it's none. The maximum depth, the feature names, okay, the class names, and we have many other optional arguments or optional parameters. Okay, so we care here about the classifier, the output file, the feature names, the class name, filled or not. So if filled equal true, then you are going to see a colored graph. So let's remove this for now and see what will be the output without this part, right? So here we have the class names are 0 and 1. The feature names are the feature names, right? So this is the one we got from here. And the classifier or the decision tree is the classifier, CLF. And the output file is the dot file we created using string IO. After that, we can create a graph from dot data, right? So inside by dot plus, this is also another library we imported specifically for visualizing the tree. We have a function called graph from dot data, right? So load graph as defined by data in dot format. The data is assumed to be in dot format, it will be parsed, and a dot class will be returned representing the graph. So the output is actually the graph. So what is the dot data? We will go to the dot data. So the dot data now contains the output file. So export GraphViz will export a dot data object in dot data, right? Which is a string IO. And then from there we have a function called getValue. So this will return the dot data. Okay, and here we are converting this dot data, this value, into a graph. Okay, so it's very similar to converting the dictionary we had before into a graph, right? And inside this graph we have a function called write_png, so we can save this graph, not only visualize it. And from IPython display, if you remember, we imported image in order to visualize the graph here. Okay, so if we run this, you will see we have this graph, right? So this is depth equal 0, this is depth equal 1, 2, 3, so we stopped at 3, right? And this was the first feature to split based on, right, the marital status, right? And the value that we split it on was married CIV spouse, right? And this was the entropy, the number of samples, okay, and the class. So if we stopped here, what will be the prediction? It will be 0. So if we predicted using a depth of 1, then we will classify as 0. Okay, now if the answer of this question is true, then we will go to this direction. So we will ask about the capital gain, and this is the entropy we will get, and this is the number of samples after we split, right? So as you can see, we have around 50% of the data is now decided, right? Or in the other part of the tree, and again we will split based on the educational number or age. If we go in the direction of educational number, then we are going to make a decision, right? We are going to say it's 0 in both cases, right? Either true or false, it will be 0. And here we will split based on the age. So if it's false, if the answer is false to this question, if the age is actually less than or equal 22.5, then we will go to this direction. So we will classify this example as 0. If the answer is false, or if the answer is no, then we will classify it as 1, and so on in the other tree, or in the other part of the tree. Now let's compare this with our own implementation. So here I have ID3 tree, right? So this is our own tree. So as you can see, the first feature to split on was index number 4. So this was actually the marital status, right? And the value that we split based on was married CIV spouse. So the same exact value that the sklearn choose. And let's go to this direction, right? So as you can see, this is the false direction. So here we have 3, right? What was 3? It was corresponding to the educational number. And here we have less than or equal 12. Here we have 12.5. So it's very, very close. And from 12.5, we go to the capital gain. So here we have 9, okay, index number 9, and this was corresponding to the capital gain. And here we are using a capital gain of 5013. Here we are using 5095.5, okay. And from there, so here we have either 0 or 1, and here we have 1 in both cases, right? So here we have 0 or 1, here 0 or 1, the left hand side will be 0, and right hand side will be 1. Here we have 1 in both cases, so that's why we didn't really build another 2 nodes. We built only 1 node because the answer is the same for both nodes, right? So that's why we have only 1 here. Let's look at the other part of the tree, which is capital gain, right? Here in our implementation we choose 9, right? So 9 was corresponding to the capital gain, right? And we choose a value of 6949, while sklearn choose 7073.5, right? And if we go to this direction, this is the true direction as we said, and this is the false direction, okay? So if we go to the false direction, you will see that we have age, right? Because index number 0 was actually the age, okay? And here we have the age less than or equal 20. In sklearn, we have age less than or equal 20.5. So there is a small, very small difference between the values, but all the attributes were chosen the same. So the same attributes we choose was the one that was also chosen by sklearn, right? So if we have an age less than or equal 20.5, then if we go to the right direction, right? If we go to the false direction, we will classify it as 1, okay? And if we go to the true direction or the true direction, then we will classify it as 0, right? And for the educational number, it's not built in our tree, so we didn't really have this part of the tree in our implementation. But if we had, then we might have gotten a better accuracy than 80%. We might have gotten like 83 or 84 like the sklearn, okay? But there is also a very important thing to notice here. First, when we split the data, right, as you can see, 17,000 examples were classified in this tree, and 14,000 example or 15,000 example, nearly 15,000 examples were in this tree, right? But after that, if you notice here, you will see that if we go to this direction, we have more than 17,000 examples in this subtree, and we have only 300 examples or 311 examples in this subtree. So this tree is unbalanced at all, and this might be a problem, and this might be a reason why the accuracy is still not like 90 or 95% or something like this, right? So when we go to the project, we will see how we can handle these problems by pre-processing the data and understanding the data better. So when we look at the tree by the end, it should be balanced or a little bit balanced like this, right? We don't really want 90 or 95% of the data in one subtree, right? Because that's not actually decreasing the entropy or increasing the information gain that much, right? So in the next lesson, we will see how we can plot the features importance and how we can see what are the most important features using the decision tree. So let's go to the next lesson.